Okay, now let's move on to actually something that's even a little more interesting than what we've been discussing so far. We'll discuss this, we'll finish out this section, then we'll take a little break. So using your bash shell scripts efficiently. So first and foremost, best practices, always start out your scripts with set-eou pipe fail. What the EO and the pipe fail together means is if any command fails, exit immediately with non-zero, with the status of the failed command. The -u means to error on any reference or any attempted use of unset variables and parameters. Now, why is that important? This type of control of our environment is very important for SREs and system administrators. We got to make sure that we know that our programs are not trying to access stuff that we don't know what the contents are of that stuff. So like variables that are not defined or unset or haven't been assigned, we don't want to access those because we don't know what they could contain. So by doing a -u in our bash scripts, we err out on that type of situation, which is good. Another little tip here is there is a linter for bash that you can run online called shellcheck. You can also download it to your Mac. And another useful tip here is get in the habit of prepending all of your variable declarations with read-only, as long as they are read-only variables. Get in the habit of prepending them with read-only. That way, again, this is, as SREs, we need to be in control of our variables at all times. And then there's two very good links at the bottom here, which the first one is a fellow who has a website that shows some useful tips, tricks, standard practices for shell scripting, as well as for like setting up your Mac OS environment. And then the last script here is a very useful thing for you to review and try to understand why is Google recommending these things. This is a style guide for shell scripting and for bash. And it's very useful to go through with it, incorporate some of those things into your own scripting, and also try to understand, well, why are they recommending that? Why does Google think that that's a standard practice? All right, now let's get into something that I like using. I like using bash rematch a lot because what I do when I script things in bash is I want to minimize calls to external programs as much as possible. So in my job, I always see a lot of scripts out there that people are writing and deploying even into production that do pipe a lot of stuff. They run a lot of in their bash scripts. They'll run a program. They'll get the output. They'll pipe it through grep. They'll pipe it through cut. They'll have a string of pipes going to get the information they want from the output of that program. And that's a waste of resources because you're making a lot of calls to external programs. You can actually do everything within bash itself without making any calls to cut or grep or awk or sed. And the way you do that is by using something called bash rematch in conjunction with regex matching in double brackets in your script. So the way that I typically use this is I will make a single external call to a command that I need the output from, and I will put all that output into a variable, and I tend to put all of the standard error and standard out combined, as you can see on this example below. And I will put all of that into a variable. Now that variable, I have it in bash, and from this point forward, I don't need to make any calls to grep or awk or anything. I can just use bash's built-in stuff, built-in features to get the information I want out of this variable, to check the variable or to extract fields from it or whatever I need to do. And so we'll go through a little example here. So for example, I'm running a PS command on my host. And what I want from this PS command is I want to know the process state and how long it's been running, one per line. So you do that with this PS command. I always like to capture both standard error and standard output into my variable, PS info here. And in my particular script that I was grabbing this example from, I wanted to convert this into an array. So I did that on the next line. And then what I wanted to do was to match the, so I've got a bunch of lines or a bunch of elements of the array. Each element is a line of the PS output. And I want to look for the zombies processes. And the zombie processes are given as the line has a capital Z at the very beginning. So the way I do that in bash without using grep or anything is I will iterate through the elements of the array. And the important part to understand here is the double brackets with the regex matching here. We've got three things going on. We've got regex matching on the Z, followed by space. And then the next thing we have going on is a parentheses. And this is a grouping. So this is a bash rematch grouping. So the parentheses, what I'm grepping for here, or not grepping, but what I'm matching on here is a time stamp. And what that allows me to do is bash rematch is a variable that will automatically get this regex match from the previous line. It'll get the contents of it. And the grouping I can extract by, the bash rematch is an array where the entire array matches the whole regex, but the individual elements of the array would match any groupings I'm doing in that regex up above. So in my case, bash rematch 1 will contain just the timestamp from the previous line. Okay. So I highly recommend delving into bash rematch if you're not already familiar with it and starting to incorporate it into your scripts, because it'll make your scripts a little more efficient, less dependent on external programs. We avoided making calls to grep and said this is good because it's slightly better for performance, maybe very slightly, but more importantly, it avoids dependence on external programs. Those external programs might have problems. There might be permissions issues. They might be missing. Their version number might behave differently than we were expecting with the previous version. Those external programs could hang. That's one of the big issues, is when you depend on external programs, they could hang. And otherwise, such things are less predictable than we like them to be. So if you can keep everything inside of bash, it's better. Okay, let's moving on with some more bash scripting best practices and understanding of bash. So background jobs in bash are kind of like the poor man's threads. They're not really thread handling, but they kind of simulate it a little bit. You can just run jobs in parallel. And they're useful if you need to do parallel processing in your bash scripts and you don't want to write a Python program, because Python has actual true thread handling. So it's no substitute for true process control, or if you need true thread handling, you would use Python. But if you don't, you could kind of do the same thing with bash background jobs. Another useful mechanism in Unix is called flock, which is for managing lock files from your shell scripts. Another useful thing that you need to get in the habit of using in your bash scripts is trap, handling error signals. So let's take a look at a little example of all of these things. In this particular little example, I grabbed it from work, something I wrote some time back to submit OpenStack LXC metrics into Wavefront. I just extracted the parts that we're concerned with here, which is trap, is the first one. So this is a good way to use trap, is to define a signal handler of your own called catch, as you see at the bottom here. And then trap will run that signal handler whenever it encounters any of these signals here, error, SIGHUP, int, or term. If it encounters any of those, it's going to run the catch routine with the argument of the line number that the error was encountered on. And so you can see your catch routine can just simply do whatever you need it to do. In my case, I'm outputting error occurred on the such and such line number. And then I'm running a cleanup routine. And in my particular case, my cleanup routine, I need to remove a temp directory that I had previously created with the make temp command. Okay, so that's a little bit of an example of a usage of trap that you can get in the habit of. Again, these slides will be available and you can go through them at your leisure and experiment with them. Let's continue on with the other parts of the script that are relevant. So for this particular script, the purpose of this was I wanted to run a function called check yum repo, which you don't see here, but that I'm just telling you that that's the function that I needed to run. And I wanted to run it on a bunch of repos, different repos simultaneously. So check yum repo would do a kind of a check on each repo. I can't remember what I was checking for. I think to make sure that it was healthy or something. But the point is that I wanted to do it simultaneously on a whole bunch of yum repos at once. Because they're independent of each other. So I could handle them all, like 20, 30, 50 of them at the same time. And the way I achieved this in Bash was up above. Basically, I created a temp folder in dev.shm to hold temporary files that my function was going to create. And I would pass it a list of yum repos. And then you can see check yum repo is run with the yum repo as argument, and it was run in the background. So running in the background means Bash is just going to launch it, and then it's going to move on. So the loop here, the for loop, meant that we're just launching check yum repo a whole bunch of times at once. So it's kind of like running multiple threads. And then in most cases, you would probably want your Bash script to wait for the child PID to finish. But in my particular case, I didn't want it because that waiting will suspend execution of the calling process until the child returns, which I did not want in this case, so I'm not using a wait here. And that's because I had more lines below this in the script that I needed to process immediately. And I didn't want to block on waiting on those children to return. So I had to do some more processing farther down. And that is kind of an example of those previous tools. And then one more thing that's very useful in Unix is to run the time command. Shows you how long your commands are taking to run. Useful for tracking the effects of changes in configurations on your system. Yes, $$ is the current PID, and that's because if we go back to my slide, that's what I wanted. I wanted the current PID because I'm considering my script itself as the parent of those children that I'm launching here on the line check yum repo line. Because I'm using that my parent PID variable later on in the script. You don't see it here, but I'm using it later on. I'm considering my script itself. Yeah, okay. Thank you for that question. Oh, sorry, I think the other guys might not have seen a question. Somebody asked, isn't $$ the current PID rather than the parent PID. And so I was just explaining. Dismiss these answered questions. And I think we're at a good point to get into a few interview questions before we go to break.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your free webinar slot today